Hi Pulkit, how are you?
Hi, I'm good. How are you?
I'm good too. So this is going to be your DSA round. I will be asking you a few DSA questions. So are you ready for it?
I'm not sure, man. Let's see.
Yeah. So let's start with the first question. So you know what BFS is, breadth first search, right?
Yeah, I think I do.
Yes. So basically, I will give you a tree in form of edge list. I will give you a few edges
Okay.
of the tree, and then I will give you a
And you'll also give me the number of nodes, right?
yes.
Yeah,
I
I
I
think
will give
from
you
the
the
number
number
of
of
edges, I
edges.
can find the number of nodes. Yeah,
Yes.
yeah.
So then I will give you the sequence, a sequence. So basically, you have to tell me whether that sequence is a valid BFS sequence of the given tree or not.
Okay, okay,
Yeah.
okay. Is it going to be a rooted tree? Like, do I know that uh, the BF is going to start? Okay, I think when you give me the sequence, I can anyway figure out from where you are starting the BFS.
Right. Or for ease, let me give you the root. So the root is going to be the node number one. That's going to be the root.
Okay, okay. Cool, cool. So, for example, let's say we have five nodes, and let's say the tree looks like one. Let's say then we have two, three, and four, and let's say we have five. I think one, two, three, four, five is valid. One, four, three, two. So you are looking for a valid breadth first search sequence, right? Breadth
Yes.
first, if I'm not wrong.
Yeah. BFS, breadth first search.
Okay. So, but the thing is that in BFS, let's say there was this node 6 also. So earlier I was just thinking that it's just that uh, basically once the nodes of one level should be completed, then the nodes from the next level should start,
Mm-hmm.
right?
Yeah.
In BFS in a tree. That is
Yes.
a necessary condition, but yeah, that's not a sufficient condition. I was just thinking about that because one, two, three, four, five, six is probably not valid because once we reach three, because we are reaching three before four,
Yes.
then six should have come before five.
Absolutely.
So I hope you guys are enjoying the video so far. Now before moving ahead, there's a very small but very important information for you all, those who are preparing for placements. सर आप लोगों को एस डी रोल के बारे में तो पता ही है. देयर इज ऑल्सो अ रोल ऑफ क्यू ए ऑटोमेशन टेस्टिंग. इसके बारे में बहुत सारे लोगों को नहीं पता होता है. ये एक बहुत ही हाई डिमांड रोल है. इसकी रिक्वायरमेंट बहुत ही ज़्यादा इंडस्ट्री में, इन मोस्ट ऑफ द स्टार्टअप्स, इन मोस्ट ऑफ द एमएनसीज. बहुत लोगों को नहीं पता होता है कि यार ये रोल क्या है, इसके लिए कैसे अप्लाई करना है एंड इसके लिए प्रिपेयर कैसे करना है. सो यार cry.do हैज़ कम अप विथ अ प्रोग्राम जो कि आपको एंड टू एंड प्रिपरेशन करवाएगा फॉर दिस प्रोग्राम एंड इट ऑल्सो गारंटीज यू अ प्लेसमेंट एट द एंड ऑफ द प्रोग्राम. तो यार आप लोगों को एक 7 डेज का फ्री ट्रायल मिलेगा. मैंने आपको लिंक दे दी है नीचे डिस्क्रिप्शन में फ्री ट्रायल की, जहाँ से आप लोगों को 7 डेज फ्री ट्रायल मिलेगा इस प्रोग्राम के बारे में. यू विल गेट टू लर्न दैट हाउ डज थिंग्स गोज इन दिस प्रोग्राम, कैसे आप लोग लाइव प्रोजेक्ट्स पे काम करके एक्सपीरियंस के साथ साथ अपना स्किल सेट इंप्रूव करेंगे. एंड देन एट द एंड ऑफ द प्रोग्राम यू विल हैव सेवरल प्रोजेक्ट्स इन योर रेज्यूमे एंड इन योर गिटहब. तो आपका रेज्यूमे प्रिपेयर होगा, आपका गिटहब प्रिपेयर होगा, आपके पास प्रॉपर स्किल सेट होगा एंड cry.do विल अरेंज कंपनीज फॉर यू, जहाँ पर जाके आप लोग इंटरव्यूज देंगे. सो बहुत ही अच्छा रोल है. डेफिनेटली चेक इट आउट. आप लोग इसके बारे में पढ़ सकते हैं, सर्च आउट कर सकते हैं. नीचे आपको लिंक दी हुई है जहाँ से आपको सारी की सारी इन्फॉर्मेशन मिल जाएगी. ऑलराइट, सो नाउ लेट अस मूव अहेड इन द वीडियो.
Yeah, right. So now, what I am thinking is that what matters to me is that whenever I am the choice that I have in BFS is that whenever I am exploring a particular node, the choice that the coder has in BFS is that in what order would he like to visit its children.
Yes.
Uh, so uh, so yeah, that is the choice, and the order in which its children were visited can probably be find out from the sequence that you will be giving me. So let's say in the sequence that you give me, it's 3 to 4, for example.
Mhm.
Uh, then from this particular sequence, it is possible for me to derive the order in which the children of 2, 3, and the children of 1 were visited. So once I know this, okay, so uh, cool. Of course, I'm trying to think of a possible, efficient solution. There could be a brute force solution as well, where we write a recursive function kind of thing to be able to generate somehow all BFS orders and then check if our BFS order is one of them. But yeah, that will be too costly. I'm thinking of an efficient one.
Yeah. And what do you
Uh,
think would be the
so yeah,
complexity
like
of the solution?
so complexity of the brute force solution
Yes.
that I just mentioned, right?
Yeah.
Okay. Mm, not completely sure, but maybe somewhat in the order of n to the power n. I'll have to explore more on that.
All right.
So, I'm kind of thinking in a manner that uh, at each stage, how many options can one have? So, not exactly n, I think n factorial, because if a node has some you know n children, for example, like the maximum number of children can be n now, but
Yeah.
they will not always be n, because they will be constrained by the fact that the number of total uh, children over all the nodes will not exceed n. But yeah, in the worst case, if I'm considering them to be n, for this particular node we have n factorial choices to choose among the orders, right? That which child should be visited first, which child should be visited afterwards.
Yeah.
So in that case, n factorial choices for dealing with children of this for one particular node, and in totality we are going to be dealing with n nodes. So that is why I thought of n factorial to the power n, but it is not a very tight uh, time complexity.
All right. All right.
So yeah, O of n factorial to the power n, but probably we could think more and analyze it better.
All right.
Okay, so yeah, coming on to the efficient solution that I was thinking.
Mhm.
Uh, okay, so once we have the node 1 with us, right? Like of course, one possible like one definitely one necessary condition, if you are telling me that the root is 1, like the BFS should start from 1, right? So the sequence that you are giving me should have 1 as its first node. That is what I'll be assuming. If not, that is not a valid sequence. But
Correct.
after that, I know that the next, the like let's say one has for in the tree, I'll know now that one has how many children. Let's say one has 3 children, as given in this example, 2, 3, 4. I know that the next 3 nodes have to be a permutation of 2, 3, 4,
Correct.
right?
Yes.
So this is something we know. And then let's say we find out that the next node is something. Okay, so then what if we so yeah, I'm just trying to see how do I implement it. The idea is becoming clear in my head. I'll always know that these next nodes have to be a permutation of these nodes. For example, now we know if let's say the next node in the sequence that you have given me is 3. From that 3, I'll know that after, like let's say it is kind of 3 to 4, and then after that I'll know, right, that after 3 to 4 are done, 6 should come. So because it is one child only, na. Had it been two childs, I would have known that a permutation of 6, 7 would come. So
Yes.
yeah, so some it'll kind of be divided into some subparts, wherein each subpart has to be a permutation of some specific nodes.
Yeah.
Does this make sense?
Yes.
But yeah, like I'm just trying to figure out how do I write it using code. Okay, so now I know the next few nodes from the current node, but that is not always going to be the case, because from 3, the next two nodes can be a permutation of 2 and 4, and then the next few nodes can be something else. Okay. And this is breadth-first search.
Anyways, how are you going to store the tree that you have just constructed using the edges?
As of now, like it will depend on the algorithm that I finalize, right? Like what all information that I need for a particular node. But as of now, I am thinking like an adjacency list, or you know, or the list of children probably. Uh,
Right. Got it.
it will depend, but yeah, like as of now, let me say adjacency list. That is what I'm thinking right now. I'll have a vector of I'll have an array of vector wherein adj of I will store the nodes that are adjacent to I, and the adjacency list of I will store basically all the children of I as well as the parent of I.
All right. And you will know by looking at the edge list, which I have provided you, you will know that the children of 1 are 2, 3, and 4, right?
Yeah, right.
And then you will insert them in the adjacency list.
Yes.
All right. So can you make utilization of that list somehow?
Yeah, sure. So from that, yeah, that helps me in knowing that just helps me in knowing that what are the candidates I'll be going to from this specific node. Uh, let me try this. What if I try to do a BFS of my own and try to match it with the uh, BFS list that you have provided?
Yes.
Kind of, I'll try the BFS in that order only. If at a point I see that there is no, I cannot take the next step, it means that the BFS sequence that you've given me is probably not valid.
Yes.
So I start with one. Let's say I have a sort of a queue where that has one in it, and then from then I have the adjacency list of uh, one, right?
Yeah.
Now I'll like when I am this particular node, I somehow have to check if the next few nodes of the sequence that you have given me, uh, do they like I have to coincide the order in of adding these children to the queue with the order of the BFS. If I'm able to do that, then I can just continue BFS and continue doing this whole thing again and again, right?
Yeah. Makes sense.
And and at a particular point, if I am not able to match the order, like the children that my children and uh yeah, so yeah, like I'm thinking like I know that my children are 2, 3, 4, right?
Yeah.
uh in if I'm a particular when I'm at a particular node, I can easily find out what my children are.
Yes.
Now what if I just find the order of those children in your given sequence? I can see now which one is coming the earliest, right?
Yeah.
uh
You can find in the sequence.
so so basically what I can do is I'm thinking of it in this manner. So the approach that I'm thinking right now will have a time complexity of n log n. I'll share it with you, but yeah, like if you think we can optimize it even more, then we can uh think of something else. But yeah, so as of now what I'm thinking is the the sequence that you have given me, right? The BFS sequence.
Yeah.
I'll store the indices of each and every node. So I'll know that. So let's say the sequence that you have given me is 4, 1, 2.
So let's start the sequence with
3. So I know. Sorry.
Let's start.
Yeah. Okay. So 1, 4. Let's say you've given me 4, 1, 2, 3, 5, 6.
Yes.
So I know that the index of 1 is 1, or index of 4 is 2, index of 2 is 3, 4, 5, 6, right?
Yes.
So if I've stored the indices for all these nodes in the given list,
Yeah.
so and now when I'm trying to do a BFS of my own, I know that my children, I know I know what all children do I have, right?
Yeah.
So what I want to do is I want to kind of sort those children on the basis of their index in the list that you've given me, right?
Got it. Yes.
Are you right? Because the child which is coming the earliest in the sequence that you have given me will come first, right?
Should be visited first in the BFS as well.
Yes. So what if I add the children? What if I sort them, right? I can write a simple comparator to sort them. Like I can basically add the children in a vector first, and then I can sort the vector based on the comparator. Okay.
Got it. Yes.
And so that is why I said n log n, because the sorting will require some time. After that, what if I just add those children in the queue in that very order, right? I'll keep on doing the BFS in this manner, and I'll keep on checking, like whenever I am hitting the first element of the queue now. Right, whenever I'm hitting the front element of the queue, I'll just keep on checking if this front element of the queue matches with the next element in the list, right?
Yes.
So keeping on matching the front elements, right? The first front element with the first element of the list, the second front element with the second element of this list, and so on and so forth. If it doesn't match, it means that there was something wrong with the sequence that you have given me, and I can say that it was not a valid sequence.
Correct.
So this is one possible approach that I thought that I can think of.
Yes, and the complexity is going to be?
Yeah, I think it is going to be O of n log n.
O of n log n because of sorting.
The sorting, yes.
Yeah. All right.
Yeah, like do you want me to try to minimize this log n thing, or do you think that's okay?
No, I'm good with it. You can just try to code it.
Okay. Cool. So we are looking for a Boolean, right? Let me just try to. So this on the doc, right? It is capitalizing automatically. I just want to see if we can.
I think you have to
disable
worry
that.
about capitalization. You can ignore it.
Okay.
Yeah.
Okay, I think I just got rid of it. So bool check BFS validity. You are giving me a vector of edges. So I'm assuming that you are giving me pair of intent edges, and you are giving me a vector of int, which is the BFS order. So here can I assume that the numbers in the BFS will be at least in the range from 1 to the number of nodes, that they will be valid,
Yes. So the nodes
that
are
is
from
okay.
1 to n.
Yeah, in the BFS as well. Okay, and in the edges as well, right?
That's correct.
Okay, so the number of nodes in this case will be equals to edges dot size plus 1, because in tree the number of edges are number of nodes minus 1, so the number of nodes will be equal to the number of edges plus 1.
Yeah.
Right. So I'll form the adjacency list from this pair of from this vector of pair of int that you have given me.
Yeah.
For that, I'll need a vector of vector int adj of size n+1,
Mhm.
and then I can iterate parent on the parent int, let's call it p on the edges, and I'll just say adj of p dot first dot pushback p dot second and adj of p dot second dot pushback p dot first. So yeah, I'm just, because this is supposed to be a bidirectional edge, right?
Mhm. Yes.
So yeah, after the edges are done, now like we discussed, we'll have a q int q, and since you're telling me that uh, I can assume that the you know root will be equal to 1, so I'm just saying q dot push 1.
All right.
Okay, so basically I'm still thinking, because I think that it should be possible to do it even without sorting, because the because the children must be present in the BFS order simultaneously, right? It's not like let's say the current node is something and it has some 5 children.
Mhm.
These 5 children will be present in the BFS order simultaneous to each other. It's not that they'll have something in between, right?
Correct. Yeah.
So this observation leads me to believe that it is possible to probably you know do them do this thing in less than O of uh, uh, and log n, because once if I just know the index of the first element, right? Let's say I have 5 children,
Mhm.
and I just need to find the index of the among my children. If I know which child is coming first in the BFS order that you have given me, the next child will be just next to it now, and the next child will be just next to it.
Yes.
Does this make sense?
Yes.
So it doesn't require sorting actually. It just needs me to uh, you know check if, yeah, I think it should be possible to do it in less than n log n. Do you want me to try the ON solution, or will we be okay with the n log n as well?
Yeah, I'm fine with n log n solution as well. But if you want to try, you can try it out.
Okay, okay. So yeah, in the O of n solution, what I need is that among my children, I need to know that which one of my which one of my children is going to go first in uh, the BFS order that you have given me.
Yeah.
That is what I need.
Yes.
So for that, one possible way that I can think of is that I store the indices like I did. I just go to them, and in sort of O of number of children, I find out that which one is coming uh, first. So yeah, that is one possible way. So yeah, let's do that. Let's do that. So how now here I'll be storing the indices. So basically ID for n+1, like we discussed, right? That we will just iterate over the. I'm assuming that the BFS order will have exactly n nodes. Is that okay?
Yeah.
So ID of BFS of I equals to I. Okay.
Okay.
So yeah. All right. Now after this, I'll have instead of the ID, I'll also have a parent array as well, which will store the parents of all the nodes.
Mhm.
So I think this is all I need. And now I can start with checking my thing. So while not q.empty,
Okay.
so the parents are initialized with 0. Okay. So while we are not empty, while it is not empty, uh, again, like the first thing to do would be to, let's see. Yeah, so to check, right? So let's call it int current equal to 0. Let's call it int id equals to 0. So let's call the current node as q.front. So if current doesn't match with the BFS of id, I would say return false, like we discussed, right? We will be comparing the first elements.
Yeah.
So let's do it like this, id plus plus, so that it is also increased every time.
All right.
All right. So now I also have to pop it up, q.pop. So now I'm interested in children of current. So now I'll be iterating over the children of current.
Mhm.
But the thing is that in the adjacency list, I'm not storing just the children,
Yeah.
right? So when I'm iterating on the adjacent list, one of these will also be equal to the parent. So that is why I needed to store that parent array as well, because when I am adding the nodes into queue now, I will also set their parent. So if ch equals parent of current, then I just continue because I'm not interested in the parent.
Mhm.
I this makes sense.
Yeah.
Now we are looking at the rest of the children. Now from these rest of the children, I'll have two things. Let's call it the number of children, although that is something that I can otherwise also find out, but yeah, that's okay. So number of children. Uh, the second thing that I needed was that which child uh, is coming on first in the BFS order that you have given me, right?
Yeah.
Because I just want to look that in what order are you entering them into the BFS order.
Yes.
So child that is coming first. So basically, first child is what I need. Okay, so first child is what I need, and let's initialize it with -1. So now here I'll say if first. So firstly, I can say num of children plus plus because this is a valid child, right?
Mhm.
And then I can say that if first child is equal to -1, or the ID of we did notice we did store the IDs, right? So
Yeah.
I'll just check on the basis of that ID. If ID of the current child is less than the ID of the first child that I have stored as of now, I will update the first child to be the current child. Okay. So
Yes.
now from this particular exercise, after iterating over the children, I'll be able to get uh, that that what is the first child, right? And from this first child, I will be able to get the rest of the children also. I hope this is okay.
How would you get the rest of the children? Because they're in sequential.
Yeah, I'll just do that right now, then and then we can discuss, right? And while doing this now, I'll also if you see now I am iterating over the children of the current node using the adjacency list. I'll also mark their parent also now. Parent
All
of
right.
everything is going to be equal to the current node. So now
Okay.
I have the parents of my children, right?
Mm-hmm.
And I also know that which of my children is coming first in the BFS order. right? So
Right.
now my argument was that if the BFS order that you are claiming to be valid is actually valid,
Mhm.
that all my children will be adjacent to each other in the BFS order, right?
Yes.
Because that's how it works. Now, whenever we pop out an element, we insert all of the children of that element once in the queue, and they
Yeah.
should be in adjacency to each other, right? In some order. I
Yes.
hope that's okay,
Yeah.
right? So now what I'll be doing is I know now that how many children are there, and I
Yeah.
know that what is the smallest index of my child.
Mhm.
What is the smallest index of some of my of one of my children in the BFS order? So
Yeah.
now,
So basically, what you are trying to say is the children, they are basically shuffled, they are permuted, but they are together, and you are trying to find the leftmost child.
yes, from the leftmost child, I can iterate to the right, and I can find the other the rest of the order as well,
Correct. Correct. Yeah.
right? And here I have a few questions to ask. Can I assume that the BFS order will also be a permutation of the nodes, or is it possible that it may have multiple nodes many times? Or
What do
can I
you
assume
mean by
because
the?
other
Yeah, it can have the permutation basically. So as we discussed in the example, right?
so it will be so it will be a permutation, right? Like what I'm asking is that the BFS order that you are giving me to check, it
Mhm.
will have one node exactly once now. It cannot have one node multiple times in the order. It will
No,
not happen now.
no.
So I can assume that it is going to be a permutation of the nodes only.
Yes.
Okay. So in that case, uh, because all of the nodes are going to be present once, and we are calculating the leftmost child, I can assume that in the right of the leftmost child, at least these many nodes will definitely be present.
Correct.
So because all the nodes are coming and are anyway coming to the right of this node now. That is why
Yes.
I was
Yeah.
just checking with you. Okay. So uh yeah, that is okay. So now what I'll be doing is I know that my starting index is going to be for int id
Mhm.
equals to let's not call it id, let's call it, because id we already used now.
Yeah.
Let's call it idx equals to id of first child, because that is where my first child is going to be, right?
Mhm.
Id is less than id of first child plus num child, right? Because I have to iterate, like, because I'm interested in num
Yeah.
ch number of nodes, right?
Correct.
And plus id x. Sorry, this should be idx again. The
Yes.
naming is something I need to work on, I think. Okay. Uh, so now, so yeah. So now from this particular thing, I know that if this particular sequence that you've given me is valid, I should be able to find all my children, right?
Mhm.
In this particular for loop, right?
Yeah.
So now I'm iterating. Now what I'll do is at let me just I think I need this braces also. So at a particular point, if I find that parent of BFS of IDX, right? So
Mhm.
is not equal to the current node, right? It means that uh, in this particular stretch of num.ch in the BFS order that you have given me, there is some node which is not my child. So it means that this is not a valid sequence,
Yes. Correct.
right?
Yeah.
Right. So I'll just return false from then and there only.
Mhm.
Otherwise, if all of the children are present in this particular stretch, it
Mhm.
means that that is the order, right?
Yeah.
So in the meantime, I'll just keep pushing q dot push BFS of IDX. So I'll have the order also same as what the order was in the BFS.
Yeah.
Does this make sense?
Yes.
So the only change, so the change which may not be very standard I did in the code was that I processed all the children at once. Maybe there was a way in which the implementation would have looked a bit smaller when we were just processing. Like we iterated on the for loop twice now. So, but yeah,
Mhm.
like this is what I could think of right
Yeah.
now.
So
So yeah,
and
after we are done, let
mhm.
me just complete the code also. After we are done now, uh, I think I should be able to return true here.
Yes.
Yeah. So this is the reason I also set the parent here, because only then I will be able to compare the parent here, because I
Yes.
should have set it earlier now.
Yeah.
So now the nodes that I am iterating here, either their parent is already set, right, and it is not equal to current, then also it is not my node. Then also it is not my child. Otherwise, if the parent is not set, then the parent will be 0. Then also it is not a valid node, because I have already set the parents of my children.
Correct. Yeah. So
Right.
the code looks good to me. And now finally, what's the complexity of this algorithm?
So yeah, it should be O of n.
O of
Time
n.
should be O of n, and the space complexity, space taken should also be O of n, because I am making a few arrays and a queue also, which can have at most
Yeah.
n nodes at a time.
Yes. Correct.
Yeah. So I think this should do.
All right. Good. So I think we have time for another question as well. So
Sure.
let me ask this question. So basically, you are given a grid, a 2D grid,
Okay.
and you basically have to tell the shortest path in which you can reach from the cell 0, 0 to the cell basically n minus 1 and m minus 1. Let's consider this to be a zero indexed grid. So you have to reach from the topmost left cell to the bottommost right cell in the shortest path. So how many steps would it take?
So I can go in any direction and all the cells are unblocked.
Yeah, you can go in any direction and all the cells are unblocked.
So you are asking the distance of the shortest path or the number of shortest paths?
The distance of the shortest path.
So I think I'm going to go from 0, 0, and so I can go towards left, right, up, down, or can I go diagonally also?
You can not move diagonally. You can basically move up in the 4 directions: top, down, left, and right.
Okay. So in that case, I think my number of steps will be n minus 1 plus m minus 1. So that comes out to be n plus m minus 2.
Correct. Absolutely correct.
So the reason being, because I have to go from 0 to n minus 1. So I have to take at least n minus 1 right steps.
Yeah,
And I have
absolutely.
to go from 0 to, sorry, n minus 1 down steps. So if I have to go from 0 to m minus 1, I have to take at least m minus 1, right steps. So yeah.
Yeah. Now, let us say that there are few blockers. Few cells are blocked. You cannot go to those cells, right? Then you will have to
Okay.
take a left turn or right turn, or maybe go from the above or down this particular cell.
Right.
So,
Right.
yeah, in the grid, there are few blocked cells. Now, how would you calculate the shortest path?
If there are a few block cells, the first thing that concerns me, that it is even possible that there is no path now from
Yeah, it
the
is.
top left to the bottom right.
Yeah.
Okay, so if it is not possible, then also I have to report that the path is not there. Otherwise, I have to tell the shortest path.
Correct.
This is the question, right?
Yeah.
Okay. So yeah, it seems to me that the neighboring cells are connected somehow, right?
Yes.
The cell 0, 0 is connected to 0, 1 and 1, 0. And in general, a cell ij is going to be connected to I plus 1j, the 4 cells, right? Left, right, up, down. I hope that is understandable.
Perfect.
So from some cell I can go to these 4 cells, and it will cost me 1 extra step.
Yeah.
So it seems like if I treat these nodes, if I treat these cells of the grid as nodes, and the connection between the adjacent cells as edges, it seems to me like a graph problem. It's just like that I want to, and of course the nodes which are blocked are the cells which are blocked. I'll not make them as a part of graph. I'll just not, if a cell is blocked, let's say if a cell ij is blocked, I
Yeah.
won't add an edge from ij to I plus 1j to
Got it.
ij minus 1, right? Because they cannot go to that particular cell. They
Yes.
will be just isolated. The blocked nodes will be just isolated. So the question remains, in my opinion, to find the shortest path between one node to from one node to another node. and before that to check if it is even possible to reach from that node to other node. So I think a possible solution is that I could just apply breadth first search from the 0 0 node, and see if while breadth, if applying breadth first search, I was able to reach n-1 or not. If I was, just return the shortest path. If not, then probably they were not in the same connected component, and there is no possible path from and there is no valid path available from 0 0 to n-1 n-1.
All right, all right. Now, let me give you some superpower by which you can unlock those locked cells, right? And let's say you can unlock
Okay. Let's say you can unblock, sorry.
K such cells which are locked. You can unlock K such
Okay.
cells. So you have this
So
capability.
at most K can be unblocked, right?
Correct.
At most K cells can be unblocked now. Okay. So now do I have to
Yeah, again
so
calculate.
basically now the question is same, right? As I calculate the minimum distance with which I can okay. And unblocking these cells is doesn't take any cost, right? It is free.
Yeah, it doesn't. Yes.
Okay. I mean that won't count in the number of steps now. Okay.
Yeah, that would not be count, but going to those cells would definitely count in the number of steps.
Right. Okay. So now I have to choose those K cells optimally so that the path is uh okay. So that hmm. So for this particular thing, first let me see, like if let's say if there is a path available from 0 0 to n-1 n-1, if I'm unblocking some cell, the shortest path will either remain same or it will decrease. It can never increase, right?
Yeah.
It will either remain same or it will decrease.
Yes.
Okay. So here I'm thinking, what if I was able to find that if I want my shortest distance to be at most x, for example, how many cells will I have to unblock? At least how many cells do I need to unblock?
Got
If
it.
I'm able to answer that question, it seems to me that binary search is something that we can think of, because there is a monotonicity in the thing that whenever I'm unblocking more cells, the shortest path is going down. So let me just think if I can. Yeah, you were saying.
To ask this, let's say you decided that this is the minimum path that you are choosing, and then you want to, for
So
this,
I'm not saying that this is the exact minimum path.
you just
I'm saying
decided,
that
checking.
the shortest path will be at most this, not exactly this.
All right. So now
That
let's
is what I'm thinking.
basically verify that if at all it is possible by removing a certain number of cells within the limit K. So how do you verify that?
So yeah, that is what I am going to think right now. Like, how can I check if this particular shortest path is achievable or not?
Yeah.
So I want the shortest distance between some node and some other node to be less than equal to this. Less than equal to some d. So here I'm thinking okay. So I am thinking of another approach now. Like I was going the other way around now.
Yeah.
What if I calculate for a particular path how many cells are needed to be blocked? I am scratching that approach I am thinking, I know that maximum K cells can be unblocked. Now, what matters to me is when I'm applying BFS,
Yeah.
let's say I also, so basically, initially we did not consider those cells as a part of the graph, right?
Yeah.
Let's consider those cells as a part of the graph. But the
Right.
thing is, if we unblock that cell, right? If we end up at that cell, we will have to unblock it, right?
Yeah.
It means that we would have unblocked one more cell. So
Yes.
basically, what I'm trying to tell you is that instead of having a state of a particular cell in the BFS, the state will be like a 2D thing, right? We are at this particular cell, I, and J number of cells have been unblocked till now.
Got it.
I hope this makes sense, right?
Yeah.
So with that state, in number of nodes into K time, right? So basically n into m into K time, I should be able to find the shortest distance. So my answer will be simply the minimum of distance of n minus 1, m minus 1, 0, n minus 1, m minus 1, 1, and so on and so forth up to distance of n minus 1, m minus 1, k.
Yeah. Correct.
Yeah.
So basically, for each path, you are trying to identify that where are you, okay, how many steps it's been to this position, but at the same time, you are also keeping track that how many extra the superpowers which are given to you have already
Yes,
consumed, right?
yes,
Yeah.
yes, yes.
Okay. So can we quickly code it?
Yeah, yeah, I can try. So now I need int find shortest path. I have probably a grid, right? So vector int, or let's call it like I'll have a grid which will tell me, right, which all cells are blocked and which are not. Can
Yes.
I assume that 0, 0 and n minus 1, m minus 1 won't be blocked?
You can assume that they are unblocked.
Yeah. So let's call it grid,
Mhm.
and uh, I'll just assume that grid value 1 means blocked,
Mhm.
or let's call it 1 means free, and 0 means
Blocked.
blocked. Okay, so let's call this free only because it is essentially telling us which all cells are free. So, and I think we don't even need it, bool should be fine. Okay, so we have the grid, and from the size of the grid we can know the number of nodes also. What else? I think nothing else now. We just, yeah, we need the k value also, so int k. Okay, so now what do we need? We need to have this distance array like we discussed. So
Yeah.
it is going to be vector of vector of int.
Mhm.
So vector of int is done. Second vector is closed. Third vector is closed. Okay. Let's call it distance. The
Mhm.
first will be n. Okay, so I'll also need this int n equals to free dot size. Here I also I'm assuming that the grid is non-empty. It has at least one row and one column.
Yeah. Sure.
M equals to free of 0 dot size. So n, and then we have vector int m comma vector int k plus 1, and let's initialize all the distances to 0 because uh, or maybe let's initialize them to minus. I'll decide later on, but yeah, I think -1 is okay.
All right.
So yeah, I opened this distance 1, 2, and this should be like this. So yeah, I'm sorry if there was some uh, mistake. So yeah, I'll just use this. Okay, so this is okay. Now I need a queue which will be of a pair, not a pair actually, it will be a triplet.
Yeah.
I, j, and number of. So yeah, let's have a vector of int only. Vector of int let's call it Q. So now initially Q dot push, we will be doing 0, 0, 0, because we are at 0, 0 and we have not unblocked any
Yeah.
blocked cell as of now.
All right.
Right, and the distance of this 0, 0, 0 will also be 0.
Yeah.
Right. Okay. So now while not Q dot empty, while not Q dot empty, I'll have the current vector. Let's call it vector of int current. Let's call it vector of int current equal to what is it, Q dot front, and let's pop it, Q dot pop, and let's have current I equals to current of 0. I think we can just have it as current of 0 later on only. So now what do I want to do? I want to iterate over the children, so basically the neighbors of this particular node. So for this purpose, I like to do it like this. So I have int di, which is going to be 1, -1, 0, 0, because these are the directions in I that I can move to. I'll have this dj, which will be 0, 0, -1, 1. So basically, there are 4 possibilities, right? So I plus 1 j, I minus 1 j, I j minus 1, and I j plus 1. So these are the 4 possibilities, right?
Yes.
Okay. So now I will be iterating on these 4 possibilities for int. Let's call it p equal to 0. P for possibility. P is less than 4. P plus p. And I know that the row I will be going to will be current of 0 plus di of p, and the column that I'll be going to will be current of 1 plus dj of p. So now, of course, if r is if r is less than 0, or r is greater than equal to n, or c is less than 0, or c is greater than or equal to m, no point, just continue.
Okay.
Right. Okay, so now I have to see about that k thing also.
Yeah.
So int unblocked will be equal to current of 2, right? So now if current of 2 is already equal to k, if I've already unblocked k, and this new is also not free, and free of r, c is basically and not free, right?
Yeah.
In that case also I can't do anything, I'll have to continue.
Okay.
But otherwise, so instead of free now, let's have it blocked. It will be a bit easier for me. So blocked, let's have it, but then I'll have to change many things. Let's let it be. So yeah, this is okay. Now let's have this int blocked equals to not free irc. So blocked will be 1 if it is blocked, otherwise it will be 0, right?
Yeah.
So now, okay, so one more thing is, now the state we will be reaching will be r c and current of 2 plus blocked. So the thing is that if blocked is 0, we will be blocking current of 2 number of cells only after reaching the new state. But if the RC is blocked, one more would have been unblocked. So this is the state we will be reaching.
Yes.
So now I'll simply say that if this of R, C and current of 2 plus blocked is not, sorry, it is, if it is equal to -1, because if it is not equal to -1, it is already in the queue. It means that it is already, we already have a better answer for this.
Yes.
If it is not, if it is equal to -1, then what I'll do is I'll just update the distance for that to be equal to distance of I. Okay, so now I need current of 0, current of 1, current of 2 plus 1. And yeah, I think I'll just push them to the queue as well. Push R, C, current of 2 plus locked.
Yeah.
Yeah, I think this should do. Now, once we are out of the while loop, so I'll just initialize the answer to be something really large, int max.
Yeah.
And then I'll just for int blocked equal to 0, blocked is less than equal to k plus blocked. If this of n minus 1, m minus 1 blocked is not equal to -1, answer equals to min of answer comma this n minus 1, m minus 1 and b. So I'm taking the minimum for all these. Now let's say you want me to return -1 if it is blocked, if there is no path available. So I'll just say return, if answer is still equal to int max, I'll just return -1, otherwise I'll just return max.
All right, awesome. So
so if answer is still if answer is still int max, it means there was no valid distance, right?
Yeah, I got the code. I just wanted to know that, let's say this part which you did at the end, you were basically trying to figure out that how did you reach to m minus 1, n minus 1, that how many basically how many cells did you unblock to get the minimum answer. That's fine, but could you do this thing inside BFS as well? Like, could you return it from BFS itself instead of calculating it again at the end?
Okay, cool, I can do that. So I'll just have to have the answer initialized before BFS. Like that was also right now. That's okay. I can do it here also, but that did not have any problem with the correctness, or the correctness was right.
The same.
I'm saying that the correctness was okay, right?
Yeah, correctness was okay.
Okay, I'll just do that. So I'm just. So now, whenever I am in this particular, whenever I'm reaching this current now, so if current of 0 is equal to n minus 1 and current of 1 is equal to n minus 1, I can say answer equals to min of answer comma this of current of this 0, 1 and 2. So yeah, this should do it for us. So now here I don't have to check if it is -1 or not, because I can be sure it won't be equal to -1.
But I think you can simply return the answer from here instead of just take.
The problem with that is that we have to check for all the different possible k values now.
So but
the thing is that, so if we had to check if it is possible to reach the n minus 1, m minus 1 node or not, then we would have returned true from there only. But you asked me to find the minimum possible distance, right? In that case, if it is possible to block even more number of cells, it is possible now that for a different value of current of 2, for a higher value of current of 2, the distance may be even less.
Yeah, but what I'm saying is basically because we are doing a BFS and because we are reaching, by performing BFS, we are reaching this cell first time, I think then we have the answer, right? Because it is already the minimum path.
Yeah, I think that makes sense. So you're saying that if it is in the queue first, then this should be the answer. Because if some other state of n minus one, m minus one comes later on, it will have it will definitely have a larger answer. Yeah, I think this makes sense.
Yeah.
So yeah, I think we can return it from here only. Yeah.
Yes.
And here we can just return minus
Yes. Perfect. So yeah, the code looks good to me. And what are the complexities, time complexity of this algorithm?
So time complexity, it looks to me that it will be n into m into k.
Yeah.
And the space also same goes for space of n into m into k.
All right. Awesome. Okay. So Pulkit, can you please tilt your screen a bit like this? Yeah. Yeah. So I think, yeah, you answered both the questions really well. And in an original interview, we can expect one out of these two questions because these two are of both hard difficulty level. And we usually expect one question only. But I bombarded you with two and you came up with the solutions really quick and coded them as well in a really neat way. And yes, and the best thing which I liked is you actually went to an approach and then you didn't like keep thinking towards that approach. You knew that, okay, now I am a bit blocked here, so let us think in another way. That kind of flexibility is very much required during an interview. Let's say if you move in a wrong direction, you should have that flexibility. Okay, you can reconsider, reevaluate the problem, and then come up with the right solution. So that was the best thing about today's interview. So yes, from my side, it is going to be definitely a strong hire for you.
Thank you.
All right, thank you.
Yeah, it was nice. It was enjoyable. I was, sort of hoping that I am able to solve in the start, but then when you gave the interview, gave the questions, and I was able to say to think of the solution, and I slowly and slowly felt safer.
Yes. All right, Pulkit. So have a good day.
Yeah,
Thank you.
thank you.